Recording in progress.
Okay. So when we got the partial fraction, how do we integrate the partial fractions? First, we need to convert the partial fraction into something that we can integrate, and then we integrate. So we're not going to integrate straight away. First thing we need to do is we need to solve this partial fraction. I got x and 2x minus 3, and let's say I got x plus a 5. So I need to convert that into normal fractions. So let's say to do that one, this will be, you just write a can be any constant, and 2x minus 3 here, plus, always a plus, b, and x plus 5. You write that one. That's the first step. After you've done the first step, what you do is you multiply. This is 2x minus 3x plus 5. This is 2x minus 3. But this is x plus 5. This denominator is different. This is different. This is different. We want to make all the denominators same. So what I'm going to do is the first one I can rewrite as it is. Okay, the second denominator, there's an a there, but I want to make it same with that one, 2x minus 3x plus 5. 2x minus 3 is already here. And the thing that's missing is x plus 5. So I would write x plus 5 here, and I will put the x plus 5 here. So I multiply and divide with the x plus 5. Yeah. A positive here. Now here there's a x plus 5 is already there, and the b is here, and I want to make it like that. So I need to multiply that by 2x minus 3, a missing bit, and 2x minus 3. Yeah. There's another way of doing it, but this is the easy and simplest way. So you got that bit. Next thing you need to do is, there's an easy way. You see all the denominators, they are same. All the denominators, they are same. So you do one more step. When the denominators are same, we just write down the denominator. Once on this side, and here you write a, x plus 5, plus b, 2x minus 3. And on this side, what I did is, because the denominator was same, I just added the top bit straight away. That's it. I just write the denominator once. Now, what you can do is, because this denominator and these denominators are same, that's one term and the other one is one term, you can just cross this bit and you can cross this bit. When you cross that one, what you got here is you just got a simple x. And on this side, you need to multiply the a inside. So that becomes a ax plus a 5a. Multiply the b inside. 2bx minus 3b. Look at that. Now, you need to find out what's the a and the b. To do that one, we need to actually group things together. If something has an x, we put them together. Something doesn't have an x, we put them together. So let's say this x on its own equals, this is a ax plus a 2bx plus a 5a minus a 3b. Okay, we got that bit. Now, I have, let me rewrite that one. X is here. If I I take the x common from these two, what I got? I got a plus 2b and x outside. Yeah. Plus a 5a minus 3b. Now, this is like a constant because a is a constant and b is a constant. Yeah. Now here, this ab is here, and there's an x. So I look on the other side of the equation, left side, right side. This is called matching the coefficient. I just match or equating the coefficient. On BS, yeah, it's both sides. Okay. Now, if you have a look, this is an x, and if you have a look on this side, there is an x, and the coefficient is 1. So, which means a plus a 2b equals 1. If they are equal, that's how it's going to work. And next thing, there is no constant. Well, there is. I can't see, but there is. It's a plus 0, which I cannot see. So 5a minus 3b equal 0.
Recording in progress.
Okay, now from here, I can find the value of the a. 5a, 3b on the other side, minus 3b becomes a positive 3b. Now a equals 3b over 5. I moved the 5 on this. So I got this way. Yeah. Now I'm just going to call this one my equation. Let's say I'm going to call this one my equation number 1. I call this one equation number 2. I call this one equation number 3. And I call this one my equation number 4. Okay. Now, this value equation number 4, I put it back here. So instead of a, I'm going to write 3b plus 5. Instead of a, I write 3b over 5. This thing, I put it here. Plus a 2b equals 1. Okay. 3 over 5 plus 2b. If I add them together, how many b's it's going to give me? 10b over 5. So that's going to give me 13b over 5 equals 1, which means b equals 5 over 13. Yeah, leave it like that. You don't need to convert that into decimal.
Recording in progress.
Okay, now I got the b, but I don't have the a. So I would take this value and put this one here. Put that value here in b, and I will get that value for the a. Okay, so now just put this one. Let's call this one equation number 5. And now I will write down. Oh, this is not visible on the camera. Put equation 5 into equation 4. So I'm just going to put that 5 into 4. Now I'll find a. So a equals 3 over 5. Now b is 5 over 13. 5 over 13. That will give me a equals 5 and 5 cancel. This 5 disappear, this 5 disappear. I got 3 over 13. So I have an a, and I'm going to call this one equation 6. I have the value of the a and the b. So these are the two values that I will need. Now, once I got these values, I will put it here. I will put it here. And then we have look at one of the rule for integration. Okay, so let me just rub the board. Okay, now we got the value of the A and the B. So I would put the value of the A here. So A is 3 over 13. I write 3 over 13 and the 2x minus 3 as it is. Plus the B is 5 over 13 and x plus 5. Okay. So what I've done is I've broken that bit into two partial fractions and I find the value of the A and find the value of the B. Rather integrating this one, which we don't know how to, we can integrate this bit. So now I can put this back into this equation and then I will integrate. So we are going to integrate this bit because they both are equal. So this side is x and 2x minus 3 and x plus 5. So now let's integrate. We are integrating with respect to x. So rather integrating that side, I will integrate the other side. So integrate 3 over 13, 2x minus 3 plus 5 over 13, x plus 5 dx. So I need to integrate that bit. Before we integrate this thing, we need to know a few things, which we already covered, but let's have a look. You know that when we integrate, the constant comes out. So let me just break it down into, let's write one more step here. So I'm going to integrate that thing. It is 3 over 13. 3 over 13, 2x minus 3. That will become plus integrate 5 over 13 x plus 5. I'm doing all the steps. If you like, you can skip few steps, not all. So the 3 over 13 is a constant, comes out, and I got 1 over 2x minus 3 and dx. Plus 5 over 13 comes out. Now the important bit. The important bit is if you look at 2x minus 3 and if you look at x plus 3, what we need to know is there is a rule. The rule states if the bottom thing, the derivative of the bottom is up, let me write the rule. The rule is like this. For example, there is, let's say, any number, like say I got 2x plus 5, let's say 2x plus 5. What's the derivative of 2x plus 5? Derivative 2, isn't it? If it's something like that, the derivative of this thing is up, there is a rule. The rule is it's ln of 2x plus 5. That's how it becomes. Okay, so what we're going to do is we are going to exploit this rule and we're going to use that one. So let's see. Okay, what is the derivative? Not the integral, derivative. What's the derivative of this thing? 2. Is there a 2 there? No, it's not a 2 there. So let's make a 2. Okay, so to make a 2, get rid of the 1, put a 2. But I can't do that. I cannot just put a 2 straight away. So what I can do is I would put 1 over 2 here as well. Yeah, balance. So now, what's the derivative of this thing? Just the 1, which is already there. So now this thing becomes 3 times 1 is 3, and that becomes 3 over 26. Yeah. And now this one, because derivative is up, I can call it ln of 2x minus 3 plus, what about this one? 5/13 is as it is. The derivative of this is up. So that's ln of x plus 5. Do not forget the plus c. Yeah, plus c is important. Okay, few important rules. If you got, guys, if you got something at the denominator and the differential of that one on the top, it's always the ln of the answer is when you integrate, it's ln of the whatever is at the thing or denominator plus a c. For example, here, let's say you got the box at the bottom and differential of the box on the top. The answer is just ln of the box plus a c. Let's do one example. Let's say there are multiple ways of doing it. There's a long way of doing it, but if you remember that rule, it's a lot quicker. Let's say I want to integrate this thing. I want to integrate that thing, and let's say it's a x cubed plus a 5x squared plus a 10. And on the top, it's a 3x squared plus a 10x. And I need to integrate this thing. It's quite difficult to integrate that thing, you know. But if I use a rule, this is what happens. I need to get that one. I'm going to call that one u. So you write down u equals x cubed plus a 5x squared plus a 10. Find me du over dx. Differentiate that one. When you differentiate that, it becomes a 3x squared plus a 10x. Now you can see this thing is on this thing is actually the numerator. And this thing is actually a denominator. So it's kind of applies, that rule does apply. So what I'm going to do is, in this one, the box is the denominator, is the box. This is the box, yeah? So in that case, I can do ln, oh, blue one, green one doesn't look nice. So ln of the denominator, x cubed plus a 5x squared plus a 10, and plus c. This is the answer in one step, yeah?
In progress.
Okay. Now we got algebraic fraction with repeated linear fractions. So this is x minus 1 fair. So that's x minus 1, then x minus 1, then x plus 1. When we convert that into x minus 1 fair and x plus 1, it's a over x minus 1 plus a b over x minus 1 plus a c over x plus 1. Now, x minus 1, the second thing we take as x minus 1 squared. So this is the important bit to know. So x minus 1 squared. Okay. Now this is the one we need. We need to find the value of the a and the b and the c. Okay, how do we find the a, b, and c? Now this three variables, it becomes a little bit more complicated. Let's have a look. So what I'm going to do is, as in first step, I will make all the variables, all the denominators same. Okay, so I can actually get rid of that bit. I can cancel the denominator. So let's have a look. Okay, I have to write all actually. That remains as it is. X minus 1 squared and x plus 1. Okay, what is missing here? What is missing here in the a? The a is still here. This is missing at the bottom. I need to make it like this. So it is missing x, this x minus 1 is still here, and it is missing x plus 1. So I write x plus 1 here. Yeah. Now I need to make it like that. So if I write x plus 1 here, I need to write x plus 1 here as well. Yeah. But I need to make x minus 1 square. So if I need to put a square here, I need to put x minus 1 on this side as well. So I have got that bit done. Now see, the denominator becomes same, but top I create that one. Now let's have a look at what I do with a b. b is still there. Now on the bottom it's x minus 1. x minus 1 square. The thing that missing is only x plus 1. So I can do x plus 1, and on the top I can do x plus 1. Now next bit, plus a c. Bottom x plus 1 is already here. What I'm missing x minus 1 square. So I'm going to write down x minus 1 square. But I have to write on the top as well, x minus 1 square. So now if you have a look, they all have exactly same denominators. If they have all the same denominator, what I can do is I can just cancel all the denominators. Yeah, because they are same. I can cancel. Let me just use a green color. I can just cancel that. I can cancel that. I can cancel that. I can cancel that. So on this side, I have 1. On other side, I have a bracket x plus 1 bracket x minus 1 plus a b bracket x plus 1 plus a c bracket x minus 1 square. Okay, now different ways of doing it. I'm going to do matching the coefficient way. There is another way as well, but let's do matching the coefficient way. First, you need to actually multiply all these bits. Yeah, you can multiply all these bits. Let me just do the other way and let me see if that's much more quicker than we. Okay, let me just do quickly. Okay. So we got that bit, then we need to actually make the coefficient same. So we want to multiply with the missing bit, so we have to make everything same. So that becomes the x minus 1. X minus 1, you put that one here, and you put x plus 1, which is here. Yeah, so you make all the coefficients same. Then you multiply these things out. All of these ones. The coefficient, the denominators are same, so you can get rid of denominators, and then you multiply that inside. When you multiply inside, this is what you got. When you got that one, you need to make sure the x squares are here. The thing that with the x are here. The thing that doesn't have any x are here. And then after that, you need to match the coefficient. So 1 is already here, a plus cx squared, plus b minus cx, because I taken the x out, and this is that one. This is a constant, that's 1. This is with the x, and there is nothing here with the x. So I'm going to add 0x, which means b minus 2c is 0. Then I can do x squared. X squared is non-existent here, so I'm going to write 0x squared, which means a plus c is 0. Now I got this bit. I can solve using a matrix formula, or you can, in your calculator, you can solve the polynomial in your calculator, and that will give you the answer as well. Let me just go. It's a menu, and then a, and then simultaneous equation. Number of unknowns are 3, and minus 1, 1, 1. 1, and that's equal 1, 0, 1, minus 0, 1, 0. And when you solve this one, they will give you the values. Use the calculator here. You can use the calculator. I will show you how polynomials equation. And that will, when you solve this one, this will give you the value of A as -1/4, value of B as 1/2, and the value of C as 1/4. So you have these three values. I'll show you later how we got these values. Now, what you need to do is, when you got these three values, you need to put it back in this equation. So let's put it back in this equation. So this equation, let me just call this one as equation 1. So I'm just going to put all these values in that equation. Now, that will become, instead of A is -1, -1/4 x minus 1. B is 1/2. 1/2. C is 1/4. 1/4 x plus 1. Once you got that thing, obviously, then you need to integrate them. You need to integrate that one. Okay. Now the integral of this one is easy. Integral of that one is easy. But what will be the integral of this one? Yeah, we have to have a look at how do we integrate this bit. Okay. Now, let's have a look at the integral. Let's do integration now, because that's what we need to do. So if I integrate this bit, let me integrate that bit. Integral of x minus 1, this -1/4 comes out. Yes, -1/4 comes out. Plus integral of 1/2 comes out. (1/4) comes out. Okay, let's have a look. According to the rule, in differentiation of this one exists on the top. Differentiation of this one exists on the top. So 1/4 is there. According to the rule, it's going to be ln of x minus 1. Okay, plus, leave that one for a while. Integration of this one exists on the top. So 1/4 as it is. Integration of x plus 1 is, did I say integration? Differential of the bottom is on the top. So when that rule is there, we write x plus 1. Plus a c. So if you write up till here, we just do the x minus 1 square in a minute. Okay, how I got the A, B, and C, I will add a tiny video for you guys, so you know how to add how to find the A, B, and C by using calculator. Yeah, but for a while, just remember that one. I got the value, and then I'll show you how. Now we know how to integrate this bit. We got the integration. We know how to do that one. Is ln. But this middle bit, I'm still stuck on the middle bit. The middle bit, I need to write it down. Let me just do that one. I need to write it down. And let me do that one separately, maybe on the top. So the middle bit, I don't have any idea. So let's do that one here. Let me rub this bit. Yeah, I'm just going to rub that one just to clear the space. Now this one, I got the half, and I need to integrate 1/x minus 1 square dx. The easy way to do that one is 1/2 and x minus 1 minus 2. I haven't integrated. It's a 2. When you move it up, it becomes a -2. Yeah? Law of indices. Now 1/2. Now when I integrate this thing, this is what happens. You actually 1 minus x, you add 1, you increase the power by 1 and divide with that power as well. That's how the integration of this thing works. So 1/2 is as it is. Here it becomes a x minus 1. Minus 2 plus 1 is -1. And at the bottom, -2 plus 1 is -1. They are multiplying. So So 2 times minus 1 is minus 1 over 2. And you got x minus 1 minus 1. Now this minus 1, we don't want to write it that way. You need to bring it down. When you bring it down, that becomes a half. And x minus 1 plus 1. Yeah, minus 1 becomes plus 1. But we don't write this plus 1. We just write like that. That's it. So this is the answer to that. So that becomes a minus 1 over 2 x minus 1. So instead of that one, I can write down there was plus. So minus 1 over 2. And then x minus 1? Yes, x minus 1. Okay, minus and positive and minus becomes a negative. So that's it. Now you can do one more step after that one. You can do one more step after that one to further simplify. There is a rule. Put all the ln's together. So I got minus 1 over 4. Actually, let's write this ln first. This ln because x plus 1. 1 over 4. I'm writing this one first because of positive. Ln of x plus 1. And after I write this one. Minus 1 over 4 ln of x minus 1. If that was positive and that was positive, I could have just straight away cancelled, but they're not. Minus 1 over 2 x minus 1 plus a c. Okay, now we have a rule. The rule is when the logs are subtracting, these are logs, ln. You divide them. So that will be 1 over 4 ln of positive 1 over the negative 1 minus 1 over 2 x minus 1 plus a c. This is your answer. Now, I'm just going to show you how we got the value of the a, b, and c, yeah, from this equation. Okay, how did I get the value of the a, b, and c by using straightaway calculator? What you need to do is you need to have this calculator, the white one, the good one. Click on the menu. When you click on the menu, you need to go all the way down, yeah, or you can just press the A. If I press the A, which is somewhere here, it's giving me simultaneous equation. Now I need to press number one. Now I'm in simultaneous equation. It says simultaneous equation, number of unknown. How many unknown I got? 3. I got 3 unknowns. Now I need to type this one. The first one I need to type in A, B, and C, A, B, and C, A, B, and C form. Yeah. The first one, what is the coefficient with the A? It's minus 1. So I type minus 1. I do minus 1. And then I press equal. Then with the B, it's a 1, and then equal. With the C, it's still a 1, equal. Then in the end, A minus A plus B plus C was equal to 1. So I can put 1 here. Then the second equation is B minus 2C. B minus 2C, I don't have any A, so 0A. B is 1. C is minus 2. And then in the end, is 0. So I add that. The third one is A plus C. So A is 1, B is 0, C is 1, and that's 0. I press that one. In calculator, it's X, Y, Z. It is not A, B, C. Then you press equal. It's give you X equals minus 4, which is A equals to minus 1 over 4. Yeah. B equals, which is Y equals 1 over 2. And then C equals 1 over 4. So that's how I got the value of the A, B, and C. Yeah. Okay.